you'll see that there's 3 terminals. This will be common, and these will be normally closed and normally open. The normally open is the start button, so when you press the start button, that will energize the relay, and when you press the stop button, that will cut the electricity off and shut off the power and turn off the relay. So 3 wires are needed. So they already have a bridge here for 2 wires, so there's going to be a wire. The line in is going to be hooked up here, and the line out will be hooked up here, going to the relay and providing relay to the power button, so the power can be cut off when you press the stop button. Be sure to feed the wires through the box. You'll notice that this is an old extension cord, and the 3rd ground wire is actually being used as one of the conductors in for the power. So I'm going to use black for the line and white and green for the stop and start buttons. So I'm going to use black for the line and white and green for the stop and start buttons. Now the start switch is wired up, so remember the wiring pattern. White is for the start to energize the relay. Green is to stop or cut off the power. And the black wire is the common supply wire. So this completes wiring up the start switch. And here are the wires coming in from the start switch. You'll notice that these are the wires from the start switch. The line in is the black power, and then these white and green are power coming into the relay. Since they're going to be energized, it's good practice to mark hot wires as with black tape on them, so others will know that they have power, they're not neutral. So here's the input cord, a cord with the plug on it, and it's going to have the 3 wires, so hot wire, neutral, and the ground wire. The ground wire will be ignored for now, but it will be connected to the ground once everything is hooked up and ready. So the hot and neutral will be most important now. So here's the relay wired up. Remember, the black wire going into the power switch was from the AC line, the line in, the hot line for 120 volts. The white wire was used for the start button, and the green wire is used for providing power to the line from to the relay and to the load. So what's happening here is there's a feedback loop on the relay side of the relay, so when the white wire energizes the coil, it brings down the power, and then the green wire here, the constant power from the switch, takes over and energizes the coil and keeps the coil energized as long as the switch is closed, or until the stop button is pressed to open the connector and stop power from the relay. So let's see how it works. So right now you'll see the wires are not insulated for easier visibility, and then you'll see on the load side is providing power to the second pole to old extension cord here for the load for the power. So it's one pole and providing power for the normally open. So when the relay is closed, the normally open connector becomes closed, and it provides power to the outlet on this old extension cord. So let's see how it works. Remember, this is very dangerous right now, so you don't want to try this at home. This would be live power. And to test the power, I'm going to hook it up to this little disc lamp here. So you'll see the power go on when the switch is activated with the start button here. So when you press the start button, the relay closes and the power flows, keeping the relay coil energized, and then the power line here is providing power to the extension cord here to keep the lamp lit. So when the stop button is pressed, it interrupts the power, breaking the circuit and turning off the relay. So with this little start button, for example, industry usually uses this maybe for 120 volts, and the relay can control 480 volts or three-phase power, so it would be less dangerous for the operator handling such a switch. And so the low voltage can control a higher voltage at the relays. Of course, this is a little itty-bitty relays, and bigger ones in industry for higher voltage and amperages exist. This is only an example. So once all this is assembled in a closed box, it would be usable. So you can amaze your friends with your vintage motor starter switch and actually working instead of leaving it unused. Now you know how to wire one up, so you can have an old-fashioned start switch you can use at home or in your workshop to control tools. And the good thing about this switch is when the power goes out and the power comes back on, the circuit stays closed, so it's very safe. So if power goes out, the power won't go back on until you press the start button again. So here's a wiring diagram for the magnetic switch project. Here's the diagram for the switch. You'll see there's two connectors. This is the black common from coming in from the line in to provide power. The start button is normally open. On the switch diagrams you'll see like a little bar above the connectors, meaning you have to press the switch to close the connections. That means normally open, so there's normally no power going through. And we use the white wire to go to the relay, and to stop, normally closed. This is providing constant power until the switch is pressed and then it's open. So this is normally closed, and you'll see a bar symbol connecting the two connectors, and this is the green wire going to the relay. Now let's take a look at the relay switch diagram. The white wire from the start button is going into the relay and providing momentary power to energize the relay coil to close the relay and provide power to the load here. So when common for pole 2 is closed, it provides power for the load, and then it completes the circuit with the house current to provide 120 volts power for the load, as you saw the lamp going on and off. So once the switch is pressed and power is provided, the line here, the green from the switch, takes over and provides constant power for the coil. When the normally open, this symbols are shown to when the connectors of terminals connected. It'll provide power to the coil until the green wire from the switch is pressed, and when the green wire is pressed, it breaks the connection to the switch and turns off power to the coil and turning off power to the load. So remember to like and subscribe and comment And come again next week for another unexpected video from the Robot VARNAC channel. So see you next week. The end for now. Goodbye.